Okay, let's dive in. Imagine this for a second. You've made these revolutionary astronomical discoveries, right?
Yeah.
But you don't publish them in some big astronomy journal. No, you publish them in a magazine about photography.
Wow. Okay. That's quite the start.
Exactly. That's actually how Ejnar Hertzsprung first shared ideas that would, well, fundamentally change how we view the entire universe.
Incredible.
So, welcome to the deep dive. Today, our mission is really to unpack the story from the source material you've shared about Hertzsprung. We're going to pull out the key insights, try to understand his really unique path, and see what this whole story tells us about discovery, persistence, and just, the power of seeing things differently.
It's such a fascinating starting point because, as the material shows, this wasn't someone born into astronomy. Not at all.
Right.
His own father apparently had a passion for it early on, but actually left the field. Told Ejnar to steer clear, find something more, well, practical.
Yeah, and it gets even more pointed when his father died. Those astronomy books they had in the house. Sold. Gone.
So it really feels like that door was intentionally closed.
Totally. So Hertzsprung trains as a chemical engineer, works in photochemistry, Russia, Germany. Light and chemicals, sure, but very much earthbound stuff.
Exactly. Mastering the science of light, yes. But his career wasn't aimed at the stars. Yet, the sources make it clear something else was calling him. That different light, the stars themselves.
That pull just didn't go away, and it brought him back to Denmark around 1902 after his mother passed away. And this is what gets me. He becomes an amateur astronomer, no formal training in it, no mentor in the usual sense.
Just driven by this core question.
Yeah, this quiet, maybe burning question. Can the universe's secrets, these massive complex things, actually be measured systematically?
And that question was everything. Because armed with that, plus his background in photography and chemical engineering, that's where his breakthrough method comes from. He started using photographic plates, literally the tools of photography at the time, to measure stellar colors with real precision. A totally novel approach back then for understanding stars.
And this connects back to that wild fact from the start. Those first major papers, 1905, 1907, laying out these revolutionary ideas.
Yeah.
They didn't go to the Astrophysical Journal or anything like that. They appeared in scientific photography magazines.
He wasn't even in the astronomy conversation yet. It's amazing.
It is, especially when you hear what was in those papers.
Right. He was arguing pretty persuasively based on his measurements that stars of the same color, same surface temperature, basically could have wildly different brightnesses. Actual intrinsic brightness.
So not just how bright they look from Earth.
Exactly. He was the first to use this photo-based evidence to say, look, some red stars are incredibly luminous. They're giants. Others are really faint. Dwarfs.
He's seeing these fundamental categories, these patterns that others just weren't picking up on.
He was. But think about the frustration. The source material really hints at this sense of isolation.
Oh, I bet. Groundbreaking stuff, right?
Huge. And it's hidden away in these let's be honest, obscure publications, invisible to the mainstream astronomers. And meanwhile, you've got Henry Norris Russell over in America, independently starting to think along similar lines.
It really underscores that challenge, doesn't it? For anyone outside the system, how do you get heard?
Yeah, how do you break through when you're not using the usual channels? It's a lesson in, well, the sociology of science, I suppose.
But his persistence did eventually pay off. The sources say fortune kind of smiled on him.
It did. Karl Schwarzschild, a really big name in German astronomy at the time, somehow he spotted the brilliance in those photography articles.
Thank goodness he did.
Right. And once Schwarzschild recognized him, things moved fast. Incredibly fast. Offers came in Göttingen Observatory in 1909, then quickly on to Potsdam.
So he goes from basically a self-taught outsider using weird methods
Totally.
to a senior astronomer at a top European institution. Like, boom, in just a couple of years.
An absolutely incredible jump, almost unheard of.
A real meteoric rise. And as his diagrams, these plots of star brightness versus color started circulating, the bigger picture sharpened. But, also controversy.
Naturally. Russell published his version of the diagram in 1913. Now, it's likely, based on the sources, he wasn't actually aware of Hertzsprung's earlier photography journal work.
Ah, okay. So maybe not intentional scooping, but...
But the result was the same. It became known, famously, as the Hertzsprung-Russell diagram, or the HR diagram.
Which leads to that classic question the material brings up. Who really deserves the main credit?
It's tricky, isn't it? The quiet Dane, who had the core idea first and published it, even if unconventionally. or the prominent American who got there independently and really brought it to the wider scientific world.
A perennial puzzle in science history. But putting the name aside for a moment, the diagram itself, the sources describe it as way more than just a graph.
Oh, absolutely. It's presented as a kind of map, a map of stellar life cycles.
Okay, unpack that.
Well, when you plot stars by their temperature or color against their true brightness, their luminosity, they don't just scatter randomly all over the place.
Right.
They fall into distinct groups, sequences, the main sequence, giants, dwarfs. And this map, it shows how stars are born, how they live, changing over millions, billions of years, and how they eventually die.
So it's like a cheat sheet for stellar evolution.
Exactly. The sources call it a Rosetta Stone for the cosmos. It became this absolutely fundamental tool. Generations of astronomers have relied on it.
Wow. Yet even after achieving that, creating this foundational tool, his path wasn't suddenly smooth. The sources point to a pretty major stumble he took in 1913.
Yeah, a critical error, actually.
Okay.
He was trying to calibrate distances using Cepheid variables,
Those pulsating stars, right?
the very ones. Their pulse rate is linked directly to their true brightness. So measure the pulse, know the true brightness, compared to apparent brightness. Bingo, you get the distance.
Sounds straightforward enough.
Except Hertzsprung's initial calibration was off, way off, by a factor of 10. He underestimated the distances massively.
Ouch. That's significant.
It was. The sources describe it almost like the universe was mocking his attempt to pin it down with numbers. A real setback.
Especially coming right after the HR diagram success, that must have stung. But the key thing the material highlights is he didn't quit.
No, he didn't retreat or get defensive. He faced it. He corrected the mistake.
And that correction was important.
Hugely important. Building on Henrietta Leavitt's earlier work connecting the period and luminosity of these Cepheids, getting that calibration right was essential.
Why?
Because that allowed him and others to use Cepheids as reliable cosmic yardsticks to measure truly vast distances, intergalactic distances.
Whoa! So the error and fixing it actually helped unlock the sheer scale of the cosmos.
In a way, yes. It's a powerful reminder that sometimes big progress comes directly from finding and fixing a major mistake. It refined the tool.
That's a great point. And he kept working, right? Moved to Leiden Observatory in the Netherlands.
He did, in 1919. Eventually became its director, stayed until 1946. And the sources mention he wasn't just a researcher there, he was a mentor. Trained future big names, like Gerard Kuiper.
Paper belt Kuiper.
That's the one. So Hertzsprung's influence continued through his students, too. He just kept refining measurements, classification. His dedication left a really deep mark.
And eventually the big awards did come, full recognition.
Oh, yes. The Gold Medal of the Royal Astronomical Society, the Bruce Medal, top honors in the field, all mentioned in the sources.
Deservedly so.
And quite fittingly, there are asteroids named Hertzsprung, even a large crater on the moon. His name is literally etched onto the cosmos he studied.
A nice cosmic touch. But the story isn't just a simple outsider makes good narrative, is it? The material revisits those controversies, the challenges.
Right. The early work being overlooked, sharing credit for the HR diagram, methods being questioned sometimes. It wasn't all smooth sailing, even after the recognition.
And the sources use these points to ask some deeper questions, don't they?
They do. Like, is true greatness just about the discovery? Or is it also about that sheer persistence when no one's listening, when you're ignored, or even when you make a big mistake and have to own it?
It makes you think, what if he had given up? Listened to his father, maybe? Or just got discouraged by being ignored early on?
Would we understand the stars the way we do now? Would we see their life stories laid out if he hadn't kept measuring, kept questioning in his own particular way? It's a powerful what if.
It really brings it back to the core lesson from his life as the sources present it. It's this testament to, well, quiet determination.
And the courage to trust your own way of seeing things, even if it's different, even if it means publishing in a photography journal.
His story reminds us, beautifully I think, that the brightest stars in science aren't always the loudest or fastest burners. Sometimes they're the ones who just endure.
Meticulously measuring, persistently questioning, illuminating the dark corners for the rest of us.
So, for you listening, when you look up at the night sky, maybe with a bit more curiosity now, remember that every star up there follows a pattern, a life cycle.
A pattern that scientists like Hertzsprung, through that persistence, helped us decipher, helped us map out.
And the material kind of turns that back on you, the listener. It asks, what patterns are you noticing that maybe others are missing?
What questions are burning quietly inside you? Maybe ones that seem impractical or, off the beaten path.
Because maybe the universe or just life rewards that kind of persistence, that seeking, that wondering.
Dare to be the outsider sometimes.
Yeah. Dare publish in the wrong journal, metaphorically speaking. Dare to make mistakes, even big ones, and then find the strength to correct them.
Let Hertzsprung's story be an inspiration, maybe, to find your own constellation of meaning. Trust your unique view.
And just never, ever stop searching for the light in the darkness.